Yeah, so when I walked in, I actually lived in Sunnyvale. My first place was at the intersection of Wolf Road and El Camino, roughly, and it bordered C.J. Olson Cherry Orchard. You know, this is basically a rural, not rural, but there was a lot of sort of farmland around here. And boy, you know, I was telling Scott that it used to be the kind of person in my generation that came to Silicon Valley was a physicist trying to replace vacuum tubes, and to see, like, you know, this crowd, it's such a change. Okay, if you could put the deck up, what I thought I'd do is kind of give people a little perspective on how we got to where we are with all of you in the room. When I came out to the Valley, this club was still meeting, and you may or may not have heard of it. If you're technology familiar, you probably did, but there was a group of kids that used to rent a room at Stanford, at the Stanford Linear Accelerator, to trade ideas and like little working designs of things that would become microcomputers. That group of kids included people like Steve Jobs and Steve Wozniak and Bill Gates and Paul Allen, also Andy Bechtolsheim and Bill Joy and the guys that started Sun Microsystems, Alan Shugart that started Seagate. And people would basically like trade ideas, and you know, all those things turned into interesting companies because of the collaboration and also, you know, timing of the market and all that stuff. So that was the era in which I came out here. A little bit of my background, I was trained as a computer chip designer at University of Illinois and ended up later getting an MBA at Harvard, but I joined a startup, and I'll get into that. I've funded 150 companies probably since 1991. I've ended up having 19 of those become public companies. I've been on 7 public boards and just seen sort of like a lot of stuff over the many years. My observation is that technology comes at us in concentric waves, and this, you know, Fintech thing we'll talk about, but it's one of the bigger ones now. Each of these little waves builds on each other, and I'm going to take you through sort of 40 years of history of Silicon Valley from an investor's viewpoint on how waves have formed, what they've turned into, what they become, how you make money in the companies that show up in them. So as I mentioned, when I first moved out here, one of the dominating companies was Fairchild Semiconductor, which, you know, if you guys know any of the history of the Valley, Fairchild was the seminal company in the area that defined Silicon Valley. Hundreds and hundreds of startups came out of that, including Intel, National, AMD, just dozens of companies that became, I think, worth $1,000 billion or more. Actually, just Intel's $150 billion, so it's probably $2,000 billion of market cap. The CEO of Fairchild popped out of there and started a startup, and I ended up being one of the marketing guys there. It's called LSI Logic, and our job was to basically turn little things that, you know, little functional replacements for things that were kind of functions inside vacuum tubes into little software models that you could aggregate and then simulate and hit a button, and then it would produce a design file for a computer chip. So that was my introduction to the Valley, and I didn't really come out here to join a business. I was just fascinated with technology because that's what I grew up doing. So that was the start of a very, very massive wave. So the first wave from an investor standpoint in the formation of technology and investment was Silicon. I moved on from there to help the government of Taiwan, of all places. They wanted to start a silicon business or silicon industry to fuel their emerging economy. And at that time, Taiwan was sort of the land of, you know, bicycle parts and belts and leather shoes. And I helped the government put together a little spreadsheet with throughput models and things on, you know, to build a factory to build silicon. Long, big wave. This company is now roughly the same market cap of Intel, Oracle, and IBM. It's like 6 Hewlett-Packards. It's 3 times Ford, 3 times Nike, 1.5 times Nike. But, you know, these waves can get very, very big. And we're at the start of one that I think is massive, which is this Fintech thing. Oops, going the wrong way. Let me go this way. So that first wave, as I mentioned, produced a ton of value in companies like Intel and all the, you know, companies you see in the silicon space. The second investable wave was taking those little things that look like Lego blocks, and people could basically take those and build little things out of them, just like your kids build stuff with Legos. But those were computers and routers and switches and hubs, so boxes of all kinds to replace big functions in, mainframes going to minis, going to workstations, going to PCs, or giant, switching systems and telephone companies becoming things that you could put, in a closet. So I think the ability for technology to reduce friction, increase scalability, it's been very, very pervasive, and it is hitting the fintech world today too. So that was wave 2. So wave 1 was making physics usable in little form factors. Wave 2 was taking those little Lego blocks and building stuff out of them, boxes. Wave 3 was stitching those boxes together. And that's kind of the LAN, the WAN, the internet that we know today that has changed everything. And I started as an investor in 1991, and it's really hard to remember what it was like to be a venture capitalist before the internet. I mean, it's actually really difficult to picture, because today there's so many things that spring out of the internet at such a rapid pace, and like I said, the waves build on each other over and over and over, and they just keep getting bigger, that the days before the internet were just kind of like, very slow-moving, molasses type of companies that took, $100 million to get off the ground. A Silicon company in that era, we would have to raise $40 to $50 million, hire 150 people, put them in a building like this. This was actually a semiconductor company in that era. I think it might have been Signetics or Philips. But we'd start building something, and it would take 5 years before you could sample a product. Literally, so we're 2016. So if you'd started one now, in 2021, you might actually sample a product, which, it's crazy the pace at which things have changed. So wave 3, build out that internet infrastructure. And I did actually start a company in that era. In that era, I was funding a chip company, and you used to have to describe the semiconductor design in a big magnetic tape. It almost looked like a movie reel. And if you were late, you basically had to take the tape, put it in a box, fly across the ocean, deliver it to a place like TSMC, and then they'd start making it. And it just bothered me that I couldn't send that file over a phone line. So I ended up buying 4 routers, and rented a T1 line across the ocean and turned that into one of the first internet services in that area. But that ended up growing to be a company that had data centers in 13 countries throughout Asia. And it went public through Goldman Sachs, Morgan Stanley, and Salomon Brothers in 2000. And at that point, I retired for a while. I started kiteboarding and became a sponsored athlete in that sport, but have never stopped investing. So that was kind of wave 3, the infrastructure part. Wave 4, things got really fun again. If you think about all these giant market value companies that you see today, whether it's Facebook at $360 billion, or LinkedIn, I forgot what it got acquired for, Twitter, all of these companies, Google too, those are really user interfaces to data coming in and off the cloud. And it's interesting because all that horsepower is in the cloud, but how do you let that out in productive, useful, interesting ways? That wave has happened so fast in a way relative to the other ones, and created so much more market value. It's mind-boggling. But it just totally unlocked a next generation of entrepreneurs. So the mobile movement, we're all part of it. Every single person in this room has a smartphone, and uses probably half a dozen or more of the apps on this page. In that, kind of the 2010 period, or 2026 through 2010, it was becoming clear that the scalability of the mobile ecosystem, driven by the launch of the iPhone later in 2007, just added a totally, kind of an exponentially bigger market in terms of the reach and just scalability. You could separate the horsepower from the cloud, virtualize the UI onto a smartphone, and reach hundreds of millions of people instantly. And now it's literally billions of people pretty fast. So, and with, I think, the social networks out there and the virality of information, when you have a hit, it can come really fast. And I started to place some bets there. I ended up in 2012, or a little bit before that, but by 2012, I had 3 of the top 30 apps in the iPhone store in terms of a funder, not a founder, but a backer. And jury's still out on some of them, but they've all done relatively well. That brings us to wave 5. So first you had physics, and then you had parts out of the physics, and then that turned into boxes, into the internet, now the UI on the outside layer. The companies that ended up winning, whether it was Facebook versus MySpace or Twitter or LinkedIn or whoever, generally speaking, those were companies that understood what was happening to their UIs. They measured the data. They knew how to drive growth, revenue, engagement, because they understood what was happening. So that, I think, brought us to, from my kind of investing framework, wave 5, which is the wave of data science, which I think is a massive one. And if you think of some brick and mortar examples in a parallel universe, you can look at some amazing retail brands from probably the 70s and 80s. Companies like Sears and JCPenney, fantastic, giant footprints, a lot of reach because they had built physical stores everywhere. And you compare the outcome over the last 10 or 15 years to companies like Walmart. If you think about what is a Walmart, Walmart is essentially a data science cloud where the user interface is a store. So they basically measure, monitor, they understand the flow of goods inside their cloud of companies. They don't have the inventory problems that Sears and JCPenney have had. They're far more efficient. They just deliver kind of product on demand where it needs to go with a little bit of inventory buffer. Dell was kind of like that in the computer business, but data science, which really has shaped the outcomes for the web giants today and had a little bit of application in bricks and mortar, it really is starting to be pervasive around everything. You're going to see a lot of it in Internet of Things, and I'll get to another example on this in a minute, but it's game changing because I think we're in an era now where if you're a company that doesn't apply those kinds of techniques, you will be gone. Because the other ones that are more efficient, they'll just out-execute on every measure on sales, customers, growth, revenue, engagement, working capital. They'll just beat you. So I think it's a very, very important wave. I'll give you an example of another company I seeded that has data science sort of at its core. The company's only 5 years old. It's really only been operating for like 3.5 in the mode that it's in. So many of you probably haven't heard about it, but this is a company, 5 years old, 3.5 years of execution, that's now running about $300 million a month in sales. Unbelievable. To get to that kind of level 25 years ago, just nearly impossible. But with mobile distribution, product flow from Asia, it's just grown. And the rumors of the company turning down offers to be acquired for $8, $9, $10 billion. So the level of value creation you can create now in 3 or 4 years is just mind-blowing. So this company, the 2 founders, one was the creator of paid search, which he did while he was at Overture. We know it more by as Kleenex's tissue. We know paid search as AdSense because Google basically replicated that kind of functionality and employed it in a bigger footprint. But one of the guys there, Danny Zhang, just brilliant. And his partner, Peter, who's the CEO, he was on the AdSense team. And they basically decided to take what functioned like an ad network where they would know what you would like to click on based on your behavior. And I don't even know what ad networks pay anymore per click, but it's not a lot. Fractions of pennies at best. And they basically substituted a view on an ad with a purchase of kind of low-cost items, and and they're all over the map. But there's some items on there for $1, there's some on there for $60, but they're basically disintermediating Alibaba. And if you think about what an Alibaba does, Alibaba created the web hosting front ends for a lot of Chinese manufacturers so people could find them and then put a marketplace on that. This allows the Chinese manufacturers to come direct. Like almost like you guys would use eBay. They can basically take a picture of the product, they can describe it, they can put it on a mobile interface, there's a library of stuff, and as you come out over to Wish, the machine learns what you guys like and then knows what to serve you as a result. So this is kind of an applied data science, which is the next wave. And the company that runs all this, as I mentioned, is Treasure Data. It's a company that I founded as chairman. The two founders of Wish and a bunch of other people in the data science and other worlds backed it with me now. But we're now basically this company, which is also about almost 5 years old now. We now ingest, I think it's 1.5 million rows of data per second, 24/7. I saw a post the other day that Instagram and Snapchat together process about 1 billion data events per day. And we do about 65 billion a day. It's between 65 billion and 100 per day because we have 211 companies now that are just using our cloud and our intelligence to drive things for them. Some of the other kinds of things we do, we for example, if you, probably no one in this room uses Grindr, but Grindr's a customer of ours. And how does Grindr know which person out of their library of millions of people to serve to the next person? That's basically a data science exercise, and that's basically coming out of us. Pebble Watch and Toyota Motors, we do some interesting things for companies like that. Companies like Toyota, we monitor about 2% of Toyota's hybrid automobiles. And to us, whether it's a phone on a network, a car on a network, or a watch on a network, it really doesn't matter. So the cars are driving around, there's microprocessors all over the car, they're generating all kinds of event data. And when those cars pull in for service, the cache is unloaded, goes into the cloud, and a company that runs that thing has basically a cloud view of what all their cars were doing and how the engines were performing across time of day and zip code and geography and air temperature and other things. So they use that data to revise how they design next generation engines. Companies like Pebble Watch, before we were integrated with them, they, I heard a rumor that the CEO basically walked in a staff meeting one day and said, well, how many watches have we sold historically and what percent of them do people use every day? And he was basically met with blank stares because no one in the room knew. So now there's a little agent in all those devices, and we collect a lot of data for them that tells them, what percentage of the people turn it on and off every day, what time of day they turned on, what applications they downloaded, whether people got stuck, whether the watch froze, what apps got deleted, what happened to the battery life. So there's a level of intelligence now available in all products that have a CPU that is just totally elevates the functionality and opens up a relationship between the brand and the customer that is just so much better than what it existed before. I already mentioned, we're growing like a weed. So that brings us to this new era. This touches a little bit on the Fintech wave that we're just starting to get into. If you think about the modern, I guess you call them asset-efficient companies, whether it's an Uber or an Airbnb, in some ways you could think of those companies as data science clouds where the UI is a car or a room. They're basically an engine that allows kind of the mapping of a set of assets, just like Walmart knew where to move its inventory from Georgia to Maine or whatever, depending on demand. This is now being applied into vertical markets in a very, very targeted way and totally remaking industries. It's happening to cars, it's happening to empty rooms, it's happening to doctors. Doctor on Demand is a company I've got a tiny investment in, but it's think of how inefficient that business is. Your kid gets sick, he's got a stuffy nose, you just want some antibiotics or something. So you call Palo Alto Medical Foundation or whoever it is, and maybe it's 2 days to make an appointment unless you want to pay $750 and come to the emergency room. and then you finally get a chance to go in and see them, and they write a prescription for you, and they send it over to Walgreens, and you wait for 3 hours, and it's a mess. So Doctor on Demand basically has aggregated thousands and thousands and thousands of board-certified physicians by state, all across the country. And when you want to see a doctor, you turn on an iPad, and there's a library of them there, and you kind of a little marketplace, and you can kind of match and look at recommendations if you want. And for simple things like that, they just sort of give you a consultation for $40. And now insurance companies see the value of this too. So some of the nation's largest insurers now offer Doctor on Demand as a service along with their insurance, because it saves them a ton of money on the back end, because it allows people to see their doctors more quickly, a little bit more preventative, and it's actually relatively inexpensive. And then that leads to this, this whole wave of Bitcoin. Who knows what happens with Bitcoin, but it's very fun. And it's opening up all kinds of new things. And this is how Scott and I started interacting a lot. But I got fascinated with that space. I can't remember, it wasn't actually that long ago, maybe 3 or 4 years ago too. And Bitcoin is very much like anything on that page. If the unit of value was a car or a room or a doctor visit, this is a unit of value. That's a unit of value that is swappable and fungible for everything else. So it's, I don't know if you call it a commodity or a currency or a store of value, but it's basically using data science as a cloud to keep track of where an asset flows. To me, it looks like an Uber. It's not expressed in the same way on an iPhone app, but it's kind of the same thing. And with it, all of there's blockchain that underlies that. You may or may not in this space have heard of Bitfury. I ended up putting together the angel round that has helped the company grow into probably the largest single processor. I like to refer to it as a blockchain processing company as opposed to a Bitcoin company. Some people call it a Bitcoin miner, of course, but it's there are a bunch of entities that you'll see in the rankings that are pools of thousands and thousands of independent companies that aggregate their their compute power together to share in proceeds. Bitfury, pretty consistently like 10 or 15% of the world market. And the company now runs data centers in Iceland, Finland, Republic of Georgia. I forgot the electricity count, but I think it's 100 million watts real time getting converted into computational power that translates into Bitcoin every second of the day. And they run this gigantic blockchain processing infrastructure, which And I want you to take a minute to read this, because I could say this, but it'll be easier for you to read it. And maybe I should read it. Anyway. Okay, so because it's probably a little far away and faded. Okay, I wrote a piece on Medium. After working with Bitfury for a couple years, I started to realize that there were a lot of other applications like those, Uber has its brand and will not be displaced, but you could basically write a little app that sits on blockchain that's Uber. You could write one that's Airbnb. You could write, there's all kinds of things that are just sort of almost like you write an iPhone app on the iPhone platform and you've got a product. I think there are ways to do lots and lots and lots of things on top of blockchain. And that caused me to really think about the trends that I'd seen in the industry and what might happen. And so, all of you sit in this space where I don't want to insult you and say you're all overhead, because you're there for a reason, but you're there to provide trust in the system. All the regulators, all the lawyers, all the backup redundant systems that probably, I don't know how many tens of billions or hundreds of billions of overhead cost structure there is to make people trust the financial system is there. But that's what everybody here is doing, I think, and so as I started to think about it, and you think about what happened in the computational waves and the other things where technology made things efficient and automated the bureaucracy so it went away. It's an interesting thought, so I will finally read this now. At its very core, to me, a bank is essentially a levered ledger of who owns what, when, with built-in time delays that allow the transactions to be authenticated and clear, whereby the bank captures the deposits, makes interest while people are kind of waiting for stuff to clear, hangs on to it, makes interest. And every time you move stuff around, they charge kind of heavy fees. And yeah, those fees are actually appropriate to the cost structures in place, but that's because all these banks have massive overhead to support all this stuff that people call trust. So that's where all of us sit in this system. All of the above is wrapped in a heavy regulatory wet blanket, forcing all these little subsystems to work together so that the aggregate system can be trusted and people don't question it. So there's layers and layers of balance sheet backup, whether it's banks, regional reserves, Federal Reserve, whatever it is. Massive hacks can occur to the system, like we had that, Bangladesh thing, even at the central bank level, and still get absorbed. Very opaque, very hefty. The system is trusted. So what happens, and I don't know how long this will take, because that's always a question, but what happens to this era's financial institutions when trust becomes implicit, just totally implicit in the system, built into the inside of the system at the core? The core itself is trust. What happens to that outer shell of layers and layers of bodies and computer systems and lawmakers and regulatory enforcers holding all this stuff into place? Do they slough off and fall away? Does the system become low friction and just kind of like the internet? Interesting to think about, huh? So I can't tell you what's going to happen, but I do have some thoughts, and I'll just make an analogy. So I'm not going to say here what happens. There's a Medium post on this, but if you think about what the phone system was like, and the reason that piece was called blockchain is to banks, as TCP/IP was to the telcos. You guys have probably seen old TV, movies or whatever, where you make a phone call and you just turn this little crank and it sends an electrical signal to an operator, and the operator answers the phone, and then you basically have something that looks like an earphone jack that connects switchboard to switchboard to switchboard to switchboard, and finally the call's complete, and you've got kind of like a long, headphone cable connecting two people across the country. That's how it used to be. A lot of overhead, a lot of bureaucracy, different kind of overhead and bureaucracy than the banks, but still, bureaucracy. And that got digitized. So eventually what happened was, rather than a physical line, everyone just connected all the lines so they were in place all the time, so the capacity was there all the time, and the phone calls would get cut up into little pieces, and all of them would just sort of flow across the system at the same time and reassemble on the other side. So far more efficient, no labor, and it just worked. And so digitization, packetization has profound effects on industry. And if the blockchain makes its way over the next 20 or 30 years, like TCP/IP and the internet, kind of infected the telco infrastructure, the whole thing's going to be remade. All services will be redefined, sitting on top of like a common core of bit flow, with identity already secure. And I don't know what happens to all the regulatory stuff. You probably, though, bureaucracy likes to save itself, so you'll all still be there making different laws, but I don't know what those laws will be. And so with that, I've got a couple projects that are just sort of interesting to talk about. I partnered up with an economist. You can see a tiny picture of him on the right there. There's a guy that I've done some work with named Hernando de Soto. And Hernando's a really interesting character. With Bitfury, I ended up getting really like kind of into the blockchain thing, and I created this thing that some of you may have heard of called the Blockchain Summit, and it's something I throw on Necker Island with Richard Branson. And we invite a bunch of really interesting people that may be needle moving in their categories to work on interesting stuff. And Hernando de Soto had written this book in the kind of the 2000 era. And in my little time off, I read it, and it just struck me. And what that book is about, he's basically defining in The Mystery of Capital, what is the root of capitalism? What makes nations work? Why do some countries evolve and have great economies and others don't? And his thesis, which I totally believed in, I still believe in, is that the basic unit of capitalism and capitalism itself doesn't come from race, religion, creed, geography, or culture. It's whether or not you have clear title to land, to a property, to an asset. And if you think about, people in unstructured environments where there's an informal economy, they're mostly squatters. They basically take what they can get out of the land as fast as they can. But if they own the land with clear title, they want to invest, make it better, grow it, and they have a clear title that they can take to the bank for a loan and build on top of that. So with that, he'd basically created the economy in a couple of countries and had done it with a very manual process of basically instituting a level of land reform and ownership of property and creating a kind of asset identity, people identity, matching those using a paper-based system. And he's been doing it for 25 years across dozens of countries. But it was a very manual process. So I got a team of developers here in Silicon Valley to look at his paper flow across a whole bunch of countries and consolidate that into a digital, iPad-based, easy, low-friction way to basically create identification of assets matched to people, suck that into a system, set it up in a set of databases, write it on the blockchain, and then you could pull it out for all kinds of things, whether you want to provision services like electricity or garbage or water or whatever it is, whether you want to collect taxes. If you want to have, basic identity on people, and you take a country, for example, like in Egypt, something like 90 million people in Egypt, 45% are under 25 years old, 80% of those are unemployed. In the Middle East, wow. That if that thing goes down, and it's been kind of like on the verge of instability for decades, if that goes down, Western, Eastern civilization, it's at risk. So we're engaged with a number of countries like that to try to give them an easy way to create a capitalist economy where people's motivations can be channeled into economic productivity instead of just being upset and joining ISIS. A second fun project, which I'll just get into very quickly because I think this is disruptive in our society if I can actually get this to happen. What you see here is the big machine there is a Bitfury mining machine. The mass of wires and red stuff, those are USB sticks that have a mining processor on them. And the kid there's my son. We have a little mining operation in our house, and he learns, how to do stuff with it. So that's basically Raspberry Pis. So a tiny little microprocessor with a little power supply, a little Wi-Fi chip, and a USB stick in the Raspberry Pi to generate the code, for Bitcoin. And this is a couple years ago. We had quite a lot of fun with this, but what a mess, like totally inefficient. And my son had the very, very great fortune, which he did not understand at the time, and I think he's coming to realize how lucky he was. But I took him to Necker Island, and he was trying to teach Richard Branson about Bitcoin mining. So we had, this little Raspberry Pi with an HDMI thing to Richard's television, displaying all kinds of code, and we were trying to find Linux drivers and get this thing to work. And it took a really long time. It took a couple of hours. And so I was saying to Richard, I said, Richard, this is such cool stuff, but this is way too hard. Somebody needs to make this as easy as screwing in a light bulb. So that's what we did. So those light bulbs are light bulbs, but inside the light bulb is a tiny little ARM processor, a Wi-Fi chip, and a Bitfury chip. So the way this thing works, you screw it into a socket, it hits Wi-Fi, you open your iPhone, open up the app, you connect to it, you're mining. So your little light bulb's kind of like making money. And what I want to see, and I'd love to see every engineer in Silicon Valley with one of these under his desk. My son, who's 15, who was 15 at the time, he wasn't old enough to get a credit card. He couldn't fill out the application because no one would take it. But he made enough Bitcoin to buy a motorcycle, which I didn't want him to buy, but he bought it anyway. So what I want to see eventually is, I'm waiting for a certain piece of silicon to come out at low cost structure, but I think it would be so cool to light up the whole next generation of kids on Facebook and give them, screw in the bulb, creates a wallet for them, they're making money, it posts to their feed, boom. I'm Bill Tai, I'm mining Bitcoin, come join me. It just goes on my feed. Anyone that clicks on it, they can get a bulb and join my mining pool. And then you can kind of send Bitcoin through Facebook Messenger or really any other messaging service. So if Facebook doesn't want to do it, I'm going to do it with Line or with Snapchat or anybody that wants to do it. But it's, and this, I'm still waiting for silicon, so this probably isn't for another year, but that, we'll see what happens. But if the world's financial system in the modern economies is redefined by stuff like this, I don't know what happens to the regulatory area there, but it's, it's just be interesting to see. So I'll just stop there. We've, I guess a minute for Q&A. Or Scott, do you want me to do Q&A or just cut it? I get done or question? I don't. Any hands? No. Oh, yeah, in the corner.
How do I get a light bulb?
Oh well, so I basically have built those at Bitfury. There's a guy named Nico Poonen who's head of product. I'm waiting for 16 nanometer silicon that should be in volume, I'm thinking, by between December and February. And we got to fill out all the Bitfury data centers. And then after that, we're going to start selling them to the public. So that's when it should be down the cost curve. And if everything hits schedule, we might have some stuff available like Q2 next year. So just stay in touch. Other? Any hands? If not? Okay. Thank you.